1, 2. Hi, I'm Valerian Callens. I work at Quantstamp, and today I will answer this question: is transient storage a transient trend? This is the plan for today, so let's start. The story of transient storage, or T-storage, started 6 years ago with EIP 1153. It was then introduced to the EVM with the Account upgrade earlier this year. And as of today, you can use it in Viper and Solidity using opcodes or the dedicated keyword transient. It's cheaper than persistent storage. Each slot is identified by a byte32 identifier. And you can keep in mind that it has two scopes. First scope is at the level of the contract, because only the contract can access its own transient storage, and you need a dedicated view function to make it accessible to other contracts. Second scope is at the level of the transaction, because transient storage only exists until the end of the transaction, and at the end of the transaction, it is set back to 0. About the use cases, the EIP initially suggested 6 use cases, including transient reentrancy guards, tokens with persistent balances but transient approvals, and tokens where you can pay a fee to unlock the token transfers until the end of the transactions. But what about the usage in practice? So you can search for this on GitHub and browse the results. You will see that most of the results are clients or dev tools trying to support the Duncan upgrade. And you will also see that actors such as Uniswap v4 or Balancer v3 are using it for flash accounting. And I listed other use cases below. As an adoption summary, most of the projects start using it with transient reentrancy guards. Then there is a common pattern for more complex use cases where you use transient context. Transient context, it's a set of transient storage variables that are used together in a consistent way. Most of the code bases also use dedicated libraries to manage their transient slots. And here is the Aussie transient slot .sol library as an example. And the adoption has been postponed in some cases. For instance, in one case, the rest of the code base was not ready for the Solidity compiler version 0824. Let's move on to the security considerations. First, when you want to check if in a function the CI pattern is enforced, consider the persistent storage, but also the transient storage. The second one is when you target an EVM network, make sure that the transient storage is fully and correctly implemented. And for this, the tool EVM diff is very useful. Then beware of the concurrency between different slots, especially when you mix inheritance and delegate calls, because you can have some slot collisions or storage slot shifts. The last consideration is for the concurrency on the same slot. And here you can think about scenarios involving account abstraction, multi-sigs, multi-calls. And basically, it's if the same transient slot can be used by multiple use cases or for multiple actors, then there is a risk of unexpected behavior or of denial of service. Let's move on to the design patterns. The first one is transient read-only reentrancy guards. So sometimes by design you cannot avoid to expose some areas of your code to read-only reentrancies. And this pattern consists in temporarily locking related view functions before and after an area. So in this example, this contract has a storage variable A, a view function getA, and a function that is exposed to read-only reentrancy. I use the arrow to delimitate the start and the end of this sensitive area. For this pattern, you give an ID to the view function, here 42. You use a modifier, and at the start of the exposed reentrancy area, you will lock the view function with a dedicated function, and you will unlock it at the end of the area. The second one, I think it's the most important, is to safely manage the life cycle of your transient context. So the rule number one is use single purpose slots. In other words, make sure that the same slot is not used for separate use cases. And the second one is to avoid parallel executions for concurrent actors on the same slots. And here is a suggestion with a pseudocode. If you have a transient context TC and an actor Bob, first make sure that the transient context is not already locked or in use. Then you lock it for Bob, you sanitize all the slots of the transient context, you initialize it, then the context is active and ready to be used, but only for Bob. When you finish, you clear the slots and you unlock it from Bob. And the last pattern I will present you today is transaction level counters. So with this, you are able to make sure that a function cannot be called more than n times per transactions, or m times per transaction per user, or any more complex logic. The advantage is that it's cheaper than using persistent storage, and also it can prevent some hacks. For instance, if a min function is used in the same transaction that redeem function in a repeated amount of time. But it has also some disadvantages because it can limit or even break the composability of your protocol in that transaction. Think about account abstraction. And once again, thinking about account abstraction, maybe some transaction batchers could abuse the system and create a denial of service in their advantage. And this is the answer to the question. So no, we are not. Transient storage is not a transient trend. We are in a healthy early adoption phase, and transient storage is here to stay. It's well documented, useful, supported by most of the networks and dev tools. The main builders are already using it, and the security knowledge exists, but still has room for improvement. I added some resources if you want to learn more about this topic. And that's it for today. Thank you.